All right, here we go. Friday before spring break. Hey, we made it a whole week of doing this. We make these videos of a day in advance, so obviously things could have changed by the time I make this video. So hopefully I'm not too far behind the times, and I'll tell you what I know. Let's go ahead and first and then let's check our homework. Checking our homework. So it was a worksheet 10.1. Here are the answers as always. Check my answers against yours. Pause the video. Answer question number 1 on Google Forms of how many you got wrong. Okay, how'd you do? If you have any specific questions, make sure you email me those questions. And as always, remember it's a video, so you can pause, rewind, play it as many times as you need. All right, so here's, as of the day before Friday, this is what I think the schedule looks like. So we're going to finish 10.2a today. We'll take spring break, woohoo. And then we'll move on. Notice it doesn't say CMAS prep with the announcement of school closure until basically we'll come back on the 20th of April. Have no idea when CMAS will be. We'll do a week's prep before the CMAS test, but as right now, since we won't see each other until the end of April, we're moving on with the rest of the material. That's actually good for us for continuity. All right, homework tonight, another worksheet. You can find the worksheet at the bottom of the Google Forms. Print it off, put it on the screen, write your answers down, whichever way you like the most is fine with me. Okay, today's a little bit of a lengthy lesson. Not sure how long the video will be, but I know it's a lot of slides. So this might be one of the ones where you might want to replay it. Big picture, it's not that challenging what we're doing today. There's only one basic new rule that you have to wrap your head around. It's pretty easy, and it happens towards the end of the lesson. 4 basic objectives. We are going to solve inequalities today, solving inequalities. All right, let's do a quick exploration. If we're in equality world, right, 6 equals 6, we are allowed to subtract anything we want as long as we don't violate the rule of algebra, which says whatever you do to one side, you must do to the other side. So if we start with an equality that's true, 6 equals 6, and we subtract the same thing from both sides, we wind up with a true statement, okay? So we say equality is maintained if you subtract the same thing from both sides. Okay, well, let's see if that's true in inequality world. If we start with a true inequality, 6 is less than 10, and we subtract the same thing from both sides, we wind up with a true inequality. So we say the inequality is maintained. Okay, we start off with a true inequality. This time I said 6 is greater than 4. We subtract the same thing from both sides, we wind up with another true inequality. So it turns out that for subtraction, you can subtract anything you want from an inequality as long as you do the same thing to both sides. So there is no difference when you're subtracting between equations and inequality. Okay? Continue with our exploration. Well, what would happen if we did not subtract the same thing from both sides? If we start off with a true inequality, 6 is less than 10, and we subtract differing amounts from both sides, well, we wind up with a false inequality. 4 is not smaller than 2. Okay, so inequality wasn't maintained. Why? Because we did not subtract the same thing from both sides. So you are good to go as long as you subtract the same thing from both sides. Here, once again, with a greater than symbol. If we subtract differing amounts from both sides, we wind up with a false inequality. Okay, so don't violate that rule. So for equality, when you are subtracting to solve, you subtract the same thing from both sides, you get to your answer. In inequality world, it's exactly the same, right? Same rules as applies from last year to this year. So we solve an inequality. Where is the variable? Left side. What's attached to it? 3. How is it attached? It's attached by addition. What's the inverse of addition? Subtraction. So you want to get rid of the 3, subtract 3 from both sides, and you get to the answer. Now, one big change. For the equality world, you're done with x equals 2. For the inequality world, we're going to combine what we did yesterday with what we're doing today, which means when you get to an answer for inequality, you must graph. Now, don't panic. It's not like a 4-minute process. It's more like a 20-second process. Draw a number line. Put one tick mark. put the number underneath. Notice that I put the 2 underneath. Open or closed circle. This one's an open circle. Read it from variable to number. X is smaller than 2, or the solutions are smaller than 2. Where are the numbers on the number line that are smaller than 2? They're to the left. Okay? So for every one of the problems we do today, yes, you need to solve the inequality, then you need to graph the answer. All right, remember you can always pause the video if you need help here. So we start with an inequality. Okay, we find the variable. We say what's attached to it. We say how is it attached, and we do the inverse. The inverse of adding 15 is subtracting 15. 3 minus 15 is negative 12. And then we need to graph the inequality. Number line, tick mark, number, open or closed circle. Yeah, this one's a closed circle. Remember, a closed circle means that number is part of the answer. We read it from variable to number. N is smaller than or equal to negative 12. Where are the numbers that are smaller than or equal to negative 12? They're to the left. Remember, if it was an open circle, it would mean negative 12 is not part of the answer. But negative 12 is less than or equal to negative 12. Therefore, we include negative 12. We make the circle solid, okay, or filled in. One more example. Okay, where's the variable left side? What's attached to it? 1.7. All right, to get rid of a positive 1.7, we subtract 1.7 from both sides. We get to the answer, and we graph the answer. Number line, tick mark, number, open or closed circle. Read it. Variable to number. D is greater than 1.3. Where are the numbers that are greater than 1.3? They're to the right of 1.3. Make sense? Okay, so these are one-step inequalities. These should give you no problems at all. All right, question number 2 is, all right, so we just solved by subtraction. Moving on, solve by addition. So we're going to do the same thing each time. We're going to explore to make sure that we can do this. If you start with a true equality and you add the same thing to both sides, you get a true equality or a true statement. So we say equality is maintained with addition. With inequality, the same thing occurs. If you start with a true inequality, 6 is less than 10. And if you add the same thing to both sides, we get another statement that is true. So we say oops, that should say inequality. There's a mistake. Inequality is maintained. Okay? All right. This works for both less than and for greater than. So if we add the same thing to both sides, we wind up with another true inequality. And so therefore the inequality is maintained. All right. What happens if we do not add the same thing to both sides? So if we don't add the same thing to both sides, bad things happen. So we get 14 is less than or equal to negative 12, which is not a true statement. So if you don't add the same thing to both sides, the inequality is not maintained. Same thing here. If we add this, different things to a greater than symbol, we wind up with a false statement. Okay? So, word of the wise, add the same thing to both sides. All right. So, adding to solve. Not to insult your intelligence, you guys have probably already got this figured out. So, where's the variable left side? What's attached? 7. How is it attached by subtraction? How do you get rid of a minus 7? You add 7 to both sides. 7 minus 3 is 4. Since it's an inequality, we need to graph the answer. Number line, tick mark, number, open or closed circle. Yeah, closed circle. Read it from variable to number. T is greater than or equal to 4, or the solutions are bigger than or equal to 4. The numbers that are bigger than or equal to 4 are to the right of 4. So there's your answer. Make sense? All right, one more. What's attached to x? Negative 3, right? How do you get rid of a negative 3? You need to add 3 to both sides, right? 3 minus 3 is 0, so we get x is greater than 4.1. Number line, tick mark, number, open or closed circle. Yeah, that would be an open circle. Let's see, x is bigger than 4.1. Where are the numbers that are bigger than 4.1? To the right. So there's your answer. All right. Same drill, you know it by now. Go ahead and work these out, check your answers, and then answer the question on Google Form for box number 2. All right, first one, n is less than or equal to 18, so that would be closed circle, shade right. On the second one, we should get n is greater than 2, so therefore open circle, shade right. Make sense? If not, rewind the video, play them again, send me an email if you need help. Cool? All right. What's the one thing that everyone hates besides? Yeah, everyone hates fractions. Well, I'll just say this. There are fractions that are truly hateful, and there's one of them right there. Algebra 2, pre-calculus, that sort of thing, you'll see fractions that look more like that, but not this year. Now be careful with fractions. They will get slightly messy. Okay, slightly messy. So let's see. Remember, whenever we have mixed numbers, I always say convert to improper fractions. The other thing, too, is we've learned how to clear fractions with equality. Now, I want you to hold off on this because there's a bit of the story that I haven't told you yet. Deals with multiplication and division, and until I tell you that part of the story, we're not going to talk about clearing the fractions. You can clear the fractions with inequalities, but there is a rule that you need to know, and I'm not going to tell it to you until later on in this lesson. Okay? All right, so let's see. If we were going to do this without clearing the fractions, we'd change everything to an improper fractions. So that would see t plus 3 times 1 is 3, plus 2 is 5, so 5/3. Okay. Notice we have common denominators, so we can subtract 5/3 from both sides. Okay. 1/3 minus 5/3 is negative. Let's see. 1/3 minus 5/3, that would be negative 4/3. Okay. Notice where I did my scratch work. Okay. So we get t is greater than or equal to negative 4/3. Okay. How do you graph that? Well, don't panic. It's done the same way. Number line, tick mark, and then you just put the number right there. Okay. Well, I mean, we know that the numbers bigger than negative 4/3 would be to the right, and the numbers smaller would be to the left. The bigger question is if we were forced to put whole numbers, which numbers, right? So let's see, negative 4/3 is smaller than 1, but bigger than 2. Or it's smaller than negative 1, but bigger than negative 2. So it's between negative 1 and negative 2. But using this technique, all you got to do is put one number. That would be a closed circle. Let's see. The answers are bigger than or equal to negative 4/3. All numbers that are bigger are to the right. So fractions aren't too bad. All right, another one. Let's see. I have no mixed numbers, so I can leave that there. So what do I got to do? I got to subtract 3/4 from both sides. So this is the one where I need some common denominators, right? So let's see. The common denominator would be 4. So 7/1 minus 3/4. I need to multiply the 7/1 by what, 4? So I would get what, 28/4? 28/4 minus 3/4 is 25/4. You're in Algebra 1. That's a perfectly fine fraction. As long as it's fully reduced, you don't need to rewrite that as a mixed number. Just write 25/4. Okay? All right, so let's see. Number line, tick mark, number. Now we got to read it. Remember, we're going to read it from variable to number, variable to number. So that says f is smaller than or equal to negative or positive 25/4. So where are the numbers that are smaller than 25/4? Yeah, that would be to the left. Make sense? Okay, fractions aren't that bad. All right, you know the drill by now. There's 4 of them. Woo, a lot of practice with fractions there. So go ahead and do those 4. All right, then check your answers and then answer the question in Google Forms for box 3. All right, the first one, we subtract 9 from both sides. That would be open circle, shade left. Bottom left, let's see, add 1/3 to both sides. That would be 16/3. Closed circle, and that one is shade. Why is that one shade right? Because notice we're going to read from variable to number. So that says x is greater than or equal to 16/3. Okay? Upper right, let's see, subtract 3 from both sides. So that would be open circle, shade left. And the bottom one, add 2/3 to both sides. Okay? And you would get 16/3, the same thing. Yes, I was lazy and put the same answer for both. Okay. However, I did switch the inequality so you'd get it a little slightly different. And I put the variable on the other side. So let's see. X is smaller than 16/3. So that would be open circle, shade left. Make sense? All right. Yes, 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 yes. You can clear the fraction. And it will make your life a little bit easier. But I got to tell you something about multiplication. Because there is a problem There is a problem with multiplication and division for that matter. Okay. The problem with multiplication is this. If we start off with a true inequality and we multiply it by a positive number, well, we get 6 is smaller than 20. Well, that's not a problem, right? Right? How about division? If we start off with a true inequality, we multiply or divide both sides, right? I'll divide this time. We still wind up with a true. So it looks like when we multiply or divide by positive numbers, life is good. However, if you're not multiplying by a positive number, we have problems. You multiply by a positive number, you don't need to do nothing. I just said double negative. You don't need to do anything. You can multiply or divide by whatever you want as long as it's positive. The problem is with negatives. If we start off with a true inequality and we multiply by a negative number, we get a false statement. Negative 6 is not smaller than negative 24. The same thing with division. If we divide by negative numbers, we wind up with a false statement. Negative 2 isn't smaller than negative 4. This is a problem. So, to get around this problem, here's what you do. You flip the inequality. In other words, whenever you multiply or divide by a negative number, you flip the inequality. What do I mean by flipping? I mean you literally, as soon as you multiply or divide by a negative number, you take that less than and you make it into a greater than. You flip it around. You take that less than or equal to and you flip it around to a greater than or equal to, or vice versa. If you start with a less than and you multiply or divide by a negative number, you flip it around. Okay. So, dividing to solve. For equality, you just solve it, right? Divide both sides by 2, you get to an answer. For an inequality, as soon as you have an inequality and you decide to multiply or divide both sides, you have to say to yourself, am I multiplying or dividing by a negative number? If the answer is yes, then you flip the inequality. If the answer is no, you do nothing except do the multiplication or division. So this particular one, 2x is less than 6. Well, to get x by itself, I need to divide both sides by 2. Okay? I'm not multiplying or dividing by a negative number, so I changed nothing. But what will change is if I ever multiply or divide by a negative number, I have to flip the inequality. So here's some examples. All right, how do we get n by itself? Yeah, we divide by 15. Okay? Did we just multiply or divide by a negative number? I'm asking that question every time I multiply or divide. If the answer is yes, you flip the inequality. If the answer is no, you do nothing. Just do the math. 45 divided by 15 is 3. Done. Graph the inequality. So that would be, what? Closed circle, shade. Oh, you're catching on now. Shade left. Okay, here's another one. How do we get rid of that negative 3? We divide both sides by a negative 3. But remember, whenever you multiply or divide by a negative number, you need to flip the inequality. So when I write the answer, I'm going to write it with a flipped inequality. Okay? So once that's done, you simply graph as you always did. Closed circle, shade right on this one. All the answers are bigger than or equal to negative 5. So for instance, 0 is bigger than or equal to negative 5. If we throw 0 into the original inequality, negative 3 times 0 is 0. 0 is smaller than or equal to 15. It works. Okay? Here's another one. So how do you get x by itself? You divide by 2. Did you just divide by a negative 2? No, you divided by a positive 2. We only flip the inequality when we divide or multiply by a negative number. Yeah, the answer is negative, but just because the answer is negative doesn't mean we flip the inequality. We only flip it if we multiply or divide by a negative number. So since we didn't multiply or divide by a negative number, then nothing changes. We just simply write the answer. Does that make sense? Make sure in big bold letters somewhere on your paper, when you multiply or divide by a negative number, you need to flip the inequality. Okay. So here's 3 of them. This is box 5. I don't know which question it is on the Google Forms. You can figure that out. Same drill. Do the math. Check your graph to my graph, and then answer the Google Form question. Okay. First one, we are not dividing by a negative. We're dividing by a positive 9. Therefore, I don't flip the inequality. So therefore, there's the answer. The second one, I am dividing by a negative 3. Therefore, I do flip. Look, I flipped the inequality. It's not a greater than. Now it's a less than. Okay, when you read that, it says x is bigger than 9. So the numbers that are bigger than 9 are to the right. The last one, I am dividing by a negative 14. Okay, it's not that the answer is negative, it's the fact that you divided by a negative. So this particular one, open circle, shade left. If that did not make sense, please play the video again or send me an email. Tell me what your confusion is. Let me help you out. Okay? All right. Last one, right? We'll call special case ones, right? Check it out. What's attached to y? -1, right? So you can either multiply both sides by -1 or divide both sides by -1. But hey, I just said I was going to divide by -1. So I need to flip the inequality. If you decide that you're dividing by a negative or multiplying, you need to flip the inequality. Okay? So open circle, shade left. Make sense? Usually the confusion happens because kids will look at the answer. Yeah, the answer was -15. The answer can be positive or negative. That's not whether you flip the inequality. You flip the inequality if you multiply or divide by a negative number. All right. Hey, remember when you're dividing with fractions, you need to do copy.flip. So on this particular one, what's attached to h? 3/4. So what do we got to multiply both sides by? 4/3. Did I just multiply both sides by a positive or a negative? Yeah, positive. So I do not flip the inequality. So multiply straight across, 4/21, that's fully reduced. So open circle, shade right. Going too quick? Remember, you can always pause. Okay. One more example. All right, what are we going to multiply both sides by? Yep, 11/6. Did I just multiply or divide by a negative number? Nope. So I don't need to flip the inequality. You can do some cross cancellation here if you want to do that first, or you can multiply straight across and then reduce. It's kind of up to you. If you're a sloppy person like me, sometimes I think multiplying straight across and then reducing is better. If you're a nice, neat person like Mariah, you could probably do your cross reduction, make your life a little bit easier. Okay, so let's see. What would be the final answer? Let's see. It would be open circle, shade left, and 11/20. Closed circle. Why did I say open circle? Yeah. Okay. Well, you got this box to do. So this is box 6. I don't know what question is on the Google Forms. You'll see it. Go ahead and do these 3 problems, and then check your answer to my answer, and then answer the Google form. All right. The first one should be n is greater than or equal to. This is the one where you'd have to flip because you multiply or divide by -1. So closed circle, shade right. The second one, we're going to multiply both sides by 5/4, so we don't need to flip the inequality. So let's see, that would be what? Open circle, shade right, because if you read it from variable to number, it says x is smaller than -20. On the last one, yeah, we're multiplying by -7/5 both sides. Therefore, we do need to flip the inequality on this particular one. So open circle, shade right. Okay? All right. Multiplying to solve, last one. Let's see. For an equality, when you got to multiply, we multiply both sides by 3. Okay. And for an inequality, we're still going to multiply both sides by 3. And just remember, we got to remember the rule. If we ever multiply or divide by a negative number, we have to flip the inequality. Okay. All right. Some quick examples. What are we going to multiply both sides by? Yep. Positive 11, so I don't need to flip the inequality. Can't cross reduce here, so that's just 33/4. So that would be what? Closed circle, shade right. Why did I say right when I meant left? Need to take a deep breath, get some oxygen. All right, next one. What are we going to multiply both sides by? Yep, -2. So if I multiply both sides by -2, I have to flip the inequality because I just multiplied by a negative number. All right, so I'm going to be left with t is greater than or equal to -44. Let's see if I can get this one right. So let's see, that would be what? Closed circle, -44, shade right. Okay, back on track. All right, quick reminder. Remember, when fractions are positive, you can have, or I say, when fractions are negative, you can write them 3 ways. The negative can be in the middle, the negative can be on the top, the negative can be on the bottom. Okay, so if I give you this fraction right here, and you want to get rid of what's attached to t, me personally, I'm going to write it as that fraction, and then multiply both sides by -5. Makes sense? Okay, so let me give you a quick example. So if you're given that fraction right there, the first step I would do is simply to rewrite it as put the negative on the bottom. Therefore, now I'm going to multiply both sides by -5. I just said I'm multiplying by -5, so I have to flip the inequality. No cross reduction here, so that would be what? -5/7. So therefore, that would be open circle, shade left. Make sense? We have arrived at our last slide. Here we go. Go ahead and do those 3. Check your answers to my answers, and then answer the last question on Google Forms. All right, first one, we're going to multiply both sides by -6, so I need to flip the inequality. So that would be open circle, shade left. Second one, I'm multiplying by a positive 13. Now, the answer is going to be negative, but that doesn't mean I flip the inequality because I multiplied both sides by a positive 13. So that would be what? Closed circle, shade left as well too. And the last one, yeah, I'm multiplying by -8. So I need to flip the inequality. Notice the answer is positive, but I still flip the inequality because it has nothing to do whether the answer is positive or negative. It has to do whether you multiply or divide by a negative number. Okay, so this would be what? Open circle, shade left. All right, well, that wasn't too bad. A little bit longer than normal. Your homework tonight is a worksheet. Good luck on that. If you have any problems, go ahead and send me an email. Remember, you can always watch this video again as many times as you want. Hey, spring break, do your homework. I will see you guys back on Monday. Expect some, or the following Monday after spring break. Expect some changes. We're discussing it as teachers right now. I'm making this video on a Thursday. We're having a teacher meeting on Friday, figure out what we want to do when we come back from spring break. We'll probably see some changes. Don't know what they will be, but we will certainly let you know. I can tell you straight up, you can probably expect that we will be giving tests when we come back. We can't go, another month without giving some tests. So we will be doing some tests as well too. Okay. All right. So have a great spring break. I know I will.